everyone! Welcome back to Wings Engine Water Settings Series Tutorial. Today is the third lesson. Today, let's take a look at for our flat water, how to set up the data controlled water surface submergence effect in real scenes. Generally speaking, like this water surface, we usually have some sensors, and the sensors may be set in different places. For example, there might be a sensor here. This sensor. And then identify the depth of the entire water surface. But in this class, we first simplify the whole problem. Let's assume we only have one sensor, such as this lake is flat. I have a sensor that can identify the entire depth of the lake. So how to twin the data of this sensor in our virtual scene? Today, we'll take you to see. Let's get ready for time. Because in the real scene, we read data from the sensors, or we need to read it directly from IoT devices, or we need to use HTTP API to connect. These two forms are not very convenient for our testing. Therefore, Wings Engine has separately provided a solution into dynamic data. Today, let's take a look at how to use this Excel data to convert it into a real-time number. Okay. The depth data obtained. Okay, let's do it manually first. This data is actually very simple. I just wrote it manually. A time field is the time when what time we collected the data. A depth field is such as 10 meters, 12 meters, 15 meters, 17 meters. After we have these two data, first, we need to into our eyes. We click on Excel. I want to emphasize again. In fact, our final. The real data needs to be imported through because I have imported it once before. So it's still here. Let's delete one. Okay. When we add the real data, we usually use API to add it. Of course, we can also use WebSocket real-time data to add. And we actually need to read directly from the device. Today, we will not only to demonstrate this effect, but also to show you when I don't have real-time data, only have static data. How can I use static data to test the function of real-time data? Okay, after we import it, we can take a look at this, which is the data we just saw. How can we test this data as a whole? From static to dynamic. We need to turn on data to broadcast one by one here. We click it. Then we can loop. We can loop 13 times, but there is a small problem. That is to say, no, because it ends with 15. It might jump back here, because it is a loop. If you only want to watch it once, don't loop it. For demonstration, I click loop here. This means that every few seconds, we broadcast one piece of data. That is to say, when I turn on the data carousel, this historical list becomes a real-time data. For example, in this second, it might be 13 o'clock, and the water depth is 10, and the depth of water is 12 meters. In this way, we can control its depth. Okay, we finished talking about this data. Automatically setting items. Let's take a look at how to bind this data to the water surface. First, we click on the plane. There is a field called position, which is our X, Y, Z. Let's take a look at Y. Directly controls Y. This is the effect. Then we just need to bind the depth of water, the water depth, to the Y-axis. First, we click Generate Data field here. Then we here. Okay, we filled in the water depths just now here. Okay, when we pull it up, generally speaking, there must be problems with you. Because we need to set a data microprocessor here. Because I've just set it. It remembers. Okay, let's delete this entire thing. Let's take a look first. If you set it directly, what it will look like. After we pull it up, we can see in the data field the water depth, because the water depth is just a data. It only has one. Let's take a look. Let's take a look at this data again. The water depth is only 1, which is 16 meters. We can see that it is already in rotation. However, the position we just generated actually has 3x, y, and z. I just need to bind the data to y. How can I bind this one-dimensional data? One-dimensional data to a three-dimensional data? We click here. There is a data microprocessing. We can see that it is defaulted to be off. When we click, after clicking Start, you'll see it gives you 3x, y, and z. In here, cola, parentheses, brackets, and a colon, value, represents the original data value, which is on our side. The data values that we set manually here. Well, the curly brackets and colon data. The data values we bind in. So for example, if we want, bind this data to y. Then we directly write the brackets and colons for x and z. Note the Chinese and English. Don't make any mistakes. It must be the English colon. In this way, these two values represent that I don't want to change them. They are the two values that I manually set, because we'll adjust it manually first. But here, we need to give it a data. Okay. After debugging, we can see that because we have 3 seconds, we can see that the data has been bounded. It changes every 3 seconds. You can see the effect. Well, at this time, you might say, the change is too abrupt. Can I make it have a transition? That's also possible. We have an option here called Enable Tween Animation. But here, I want to remind you that because our default enables tween animation, it is a path animation. It will rotate with the angle. At this time, we don't want it to rotate at any time. For example, if it's going up and down straight, you must click the plane in advance. And then turn off the follow path rotation here. First, after version 4.6.0, our plane will not have this. It's turned off by default. But if you are before version 4.6.0, remember to turn off. Turn off the follow path rotation first. Then go to the data here. Click on the startup animation. Everyone can wait a moment. Let's go to the shore to take a look. You can see that at this time it has already. There will be a slow and slow. Just now, because it was the whole. I said, because it is a whole cycle to the end. Normally, as the data keeps going down, there won't be such an effect. Okay, you can see it slowly rising. Okay, let's go. This is the effect. Well, some students might still say that the 0 point of my position. This is different from the 0 point of your test. What should we do? In the same way, here we are. In the data per processing. For example, our default 0 point is at this position, right? The test 0 point of your water depth is actually in the air, such as about 10 meters. The depth of your test. With our reel, the coordinates in the twins, it should be a relationship of adding 10. But we don't add 10 here. If we add 10, it may be too high. Let me subtract a little bit to show you. Subtract 10. I'll subtract 5. Okay, so in this way, it's equivalent to me. The data of water depth is at the position of -5. To do it, how to deal with this thing? That is to say, everyone must, according to the real world, the origin of the depth measured in the real world, and the origin of the twins seen. The origin of the twins seen. To make a correspondence, for example, if it is 5 lower or 10 higher, even if I need to multiply the depth of water, I can multiply it by 2. You can directly write the formula here. Okay, in this way, we've created a very real water-changing effect. However, this is through our static data. To fake this effect, this is when we are testing or when we are demonstrating. In real projects, we should use our data replacement function directly to replace it. Then we have a feature called replacement data. We can replace the data of water depth data with another data. Then it will directly. Function is good. Everyone, of course, because we have this here. That is, at the data level. We have such a setting at the data level, so we can make it show such a dynamic effect. After you replace it, you can set the data. Because of that data, the data that is replaced, such as API or WebSocket, is originally a real-time data. Don't turn on the part animation. Okay, that's all for today's class. Let's review it again. We use a static data source to simulate a dynamic data source, and then bind the data to this location. But at the same time, we should remember, we still have 2 settings. The first setting is data microprocessing. We tell our data the binding of a data. Which part should keep the original data value? And which part should use the dynamic data value? The dynamic data values we bounded. Meanwhile, we also have a startup interpolation. After the startup interpolation, it 1 TB slow. It will slowly. It won't jump up and down. Okay, that's all for today's class. Thank you all.